Hello, everybody. Welcome again. Thank you for joining us this evening or this morning or late night, wherever you might be. Today, we're going to talk about data science careers, the most typical ones that are out there, the skills needed, the backgrounds people bring, salary expectations. So it's a pretty good time still to be in the world of data. There are a lot of different types of roles that are out there that we're going to go through. We're lucky to get people, again, from more than 10 countries this time to register for the webinar. So it's great also to see the global interest in data science in general. My name is Alex Chisholm. I am the co-founder of Data Query, a website that hosts now, I think, about 2,500 data science learning courses and resources for you to find to achieve your career goals, to find some of these roles and the courses and the skills necessary to excel in them. And I'm joined by my co-founder, David. David, do you want to say hello?
Hi, everyone. Yeah, it's good to be here. I'm excited to talk about the data roles. There's a lot of great opportunity, out there in the world of data science, and this is just a great topic.
And David and I have been working together at this stage for probably 10 years at least, maybe a little bit longer.
Yeah.
And we've kind of gone through our data career together in some ways, focusing on different aspects of it. But in thinking of this webinar, we were sort of brainstorming the titles that we've had around the world of data science. And I think when I first worked with David, you were some kind of statistical analysis manager. Is that right?
Yeah, that's right.
Yeah. And then we had, I've been a head of analytics. David is now a data scientist, senior data scientist, I believe is his formal title. So they're market research analyst, director of statistical analysis, business analyst, senior data analyst. And you just think of the CVs that you and I have sort of put together in these random data roles. It's been interesting to see how they've evolved, I think, over the last 10 years, because these definitions and these roles haven't stayed the same, have they?
No, and I mean, the one thing I do like is it seems like back in the day, the titles were very specific. So you were a marketing analyst or a business analyst, so very specific to the role. But now they've become more broad, which makes it easier because they focus on just the high-level skills you need to perform that job in any function or any industry. So I like that it's shifted towards data analyst and data scientist, data engineer, and they're all very clear kind of roles within the data space these days. So I think it's easier than ever for people entering the field to know which way to kind of navigate, with all the training and things like that available these days.
Yeah, totally. And being able to get up to speed in a specific role is easier than ever as well, because you've got universities and business schools and companies putting together content that's walking people through the skill sets and the techniques that are needed to excel, to even get your foot in the door for one of these positions.
Yeah, definitely.
So let me just give everybody on the call an overview. We've got about an hour together. We're going to cover a few basic slides with some data that we've been looking at recently. Last year, we went out to about 5,000 job posts around the world. We got all the text data. We did some very light natural language processing on it. We extracted some meaning from it. But primarily tonight, we're just going to be looking at the frequency of certain tools, techniques, backgrounds that are being asked on some of these specific job roles. So we're going to do some comparing and some contrasting. If you have any questions along the way, feel free to throw them in the chat box, or the Q&A box is the one I believe you can see. And we'll be happy to answer questions as we go. And other than that, we will share the slides. We will share any of the other materials or links that we're going to be sharing with you as well. And with that, I'll start by sharing my screen and getting into this light presentation. So what we want to do tonight is focus on really 6 of what we would say are still the primary roles that are out there. And David mentioned a lot more clarity around these now in terms of what's being asked of them. But even within each one of these categories, of course, depending on your company, depending on your level of expertise, you're going to have different types of responsibilities that might be thrown at you. So we're going to cover the analyst side on business and data analysts, get into data scientists, data engineers, and data architects. And then finally, this executive level role that is becoming more common as organizations continue to go through their data transformation, the chief data officer. Yeah. But the unifying trend, I think, around all of this, or not really a trend, but the unifying reality is that each of these positions, the underlying theme is taking data that's available or creating new data and finding ways to get value out of it. So regardless of which role you might find yourself in, you're going to have to find some way to understand what is the problem your team, your company, your clients are trying to solve. What are the tools available to you? And how can you mash these together to come up with something that's useful and that's practical? Yeah. And I think, David and I have worked in the past on projects as well, where, when you get too theoretical and you forget the business implications around all of this, you're kind of going to be lost, flapping in the wind, right, David?
Yeah, that's right. And I feel like sometimes there's been many training and maybe even university courses that focus too much on the techniques of data science and the math behind the models and all these things, when I think the best thing you can learn starting out is how to become an expert in a company's data and in their business. If you can develop that skill where somebody will approach you and say, I've got this idea for this product, can we do this? Can we use machine learning to do it with our data? If you know that, if you can answer it very quickly, if you know which assets you have and tables you can go to, that is really, incredibly beneficial. That will make you almost a rock star at any company, is just having a deep knowledge of their data. So I feel like that's kind of skipped over, sometimes, but extremely important these days.
How do you find, what is the easiest way to achieve that in a short period of time? Because I know it's hard when you get, by the way, we should say I'm in Amsterdam, in the Netherlands right now. David is in Virginia. When I first moved to Amsterdam 6 years ago, I joined a company. It was a startup company, a different sort of style and pace than the one I was coming from. And instead of millions of records of data coming in maybe once a year, it shifted to hundreds of millions of new data points being generated very frequently. And how do I go through, one, process that data, but even understand what the variables are and how they're connected? Do you have a way to accelerate that when it can feel overwhelming at first?
Yeah, the important thing is to know the correct technology to approach the problem with in the beginning. So if you have anything more than, I think, 5 gigabytes, your laptop and anything on it usually doesn't work, right? So that's when you need to really start thinking about tools like Spark for big data, using cloud computing, because you won't be able to achieve your goals without the proper tool. But the best way to really understand the data and the processes is just to think about, I don't know, maybe the people behind the processes and how that data is being generated. So I remember in my previous roles, to really understand a particular product, I would go into the app and be a test user. I would take certain actions and I would see how that would translate into the databases and how it was recorded. And that's where you really pick up on all the nuances and potential issues that can come up with capturing the data incorrectly. So that's definitely not a quick way to do it, but that's the quickest way. If you can get into the processes, if you can talk to the people running the business and see how all this is generated, and then map that in your mind to your databases, that will set you up for success, I think, ultimately.
Yeah, it sounds like you're finding a way to personalize the data that's being generated. So one, you have an intimate knowledge of how it's being constructed, which makes it a lot easier in terms of what you can do with it. But also just getting an understanding and an empathy for the other people who are either creating it or setting the process up to collect the data, or their goals for using it. The one other recommendation I would have, and because we get this question a lot, when you're going through your data camp course or your Coursera course, it's very easy to just use the data examples they give you, make sure it works with the code that's being shown and just run it. But more than likely, no matter how interesting that data set might be, that the demo one is, you're not going to fully understand it. You're not going to understand how it was collected or why it is important or what could be done with it or what the business questions are. So what I would really recommend, it's not big data here. It's find a small data set that you love, that you know really well. And as you're going through, or one that you really want to learn and you care about, and as you're going through these courses, start with the examples they're showing you with the data. Make sure the whatever method, whether it's Excel or Python or R or Spark or whatever, make sure it works. But then slowly transition and work in your data set into this. And then the questions you're going to start being able to answer with these tools, I think, will just become that more personalized for you.
Mm-hmm. Yeah.
So what we're going to do, we want to think a little bit about what the overlap is here. David mentioned earlier, like there's becoming more clarity now as, until 10, what was the first PhD in data science? When did that come out, David? In the last decade or so, right?
That must have been about 10 years ago or so. I know that the first chief data officer role came out about 20 years ago in the 2000s or so. I think Capital One had the first official chief data officer.
Right.
And that's pretty recent too.
Yeah.
I mean, it's all very new. So.
Right. So you've got a lot of people, and I'm guessing that chief data officer didn't have a PhD in data science. Of course, they did not. They had no degree in the data science space or artificial intelligence or ML or whatever it is, most likely. So as things progress, as more people are going through university settings and professional world with more clarity in their jobs, it's going to become a little bit more formalized. But in some ways, data science roles kind of are acting like a startup themselves right now, as you're not exactly sure, depending on what organization you're in, exactly a data scientist might look like versus that data analyst in some cases. Part of this might just be the company in general. They might not know or understand really what they want from a role. So we're going to have this overlap here. And there's a link that you can get from the slides when we send it on the bottom to an article now that's probably 2 or 3 years old, maybe more. But it tried to map out, what does that Venn diagram of data science look like? And there's a lot of debate and argument online about, what the proper one is. But I think stylistically, this one was always helpful to me, maybe because it was very simple. It was just kind of, one-dimensional. You've got the computer science skill set, you've got statistics and modeling, and you've got business perspective. And traditionally, you would have the business analyst over there on that business perspective side. On the other side, the data engineer on the computer science side. And then this data scientist, the sexiest role or whatever that came up, was kind of in the middle of this. It would have to understand, what this person could do with data to apply advanced modeling to things to make the business sort of run. And they'd also have to rely on the data engineers to make sure they could set up environments in which these models could be executed in a value-added, scalable, reproducible way. So right now, I think this range still works, and you see like the top 5 doing roles that we're going to talk about tonight up top, and then you've got the more senior manager, leadership roles down below with the data architect and a chief data officer. We're gonna define each one of these, but the only thing I want to be cautious about is when you are interested in looking for that data engineering role. Depending again on this organization that you're going after, one might read completely different than the other. And that could be because the problems that are being solved by that one organization are just very different than the other. Or it could just be they have just different understanding of what these people should be contributing to what the organization is trying to achieve.
Yeah, and you really have to also consider company size. So the smaller a company gets, the smaller the data science department, the more blurred these Venn diagrams become. Eventually you'll have to kind of do a little, piece of everything if you're at a smaller organization, with fewer resources, which I think is great. I mean, that's how we started off, in data science. We didn't have these roles. We were at a smaller-ish company, and you really had to do the whole entire process, which I think is a great learning experience. It's always good to go through the whole thing because you can feel everybody's pain, right? All these roles because you've gone through it. So it's helpful. But.
Yeah, and you balance it on the other side. If you go into a company that's 10,000 people deep or 20,000 people deep, their data analyst role is probably pretty narrow in terms of what they know and think that this data analyst needs to do to contribute to that big machine. So it might be a very efficient environment you're going in. Your team might be achieving a lot of success, but you might miss out on some of those opportunities to sort of spread your wings a little bit and find out, go a little bit into that data science side or through it a little bit to the data engineering role or work closely with executives. So there are definitely pros and cons on either side.
Yeah.
So let's get right into it. We're going to go through this I think 6 dominant roles that we have some information on our website. And as I mentioned, we went through about 5,000 job posts last year. We went through all of the descriptions and we pulled out, what are the tools and what are the techniques? What are the keywords that come up the most? So we're going to look on each one of these slides. On the far right here, you can see on the top are the tools, and then on the bottom are the techniques. And this is just saying of all of the job posts we looked at for business analyst, Excel was explicitly mentioned 31% of the time. So, and you can imagine some of these job posts were quite long. They threw everything in there, and you've probably seen the job posts that are very, very minimal and more theoretical or aspirational. It's more about the beanbag chairs and the beer on tap than it is what might actually be getting done within the role. So I think it's interesting to see within one specific role here. But then at the end of this, we're going to look across all of the roles and kind of how these tools and techniques come up. And a lot of interesting trends come from that as well. The other thing I'll define before we get into it, you can also see there's a US dollar annual salary base salary figure shown here. It's incredibly hard to show salary data, again, because of company differences, geographic differences, levels of experience, all of that stuff. This is taking the average of, the pay scales of the world, the Indeeds, the Glassdoors. It's an average of their averages, but it has a US focused. So if you're calling in from outside of North America, these might be very different, obviously, both in terms of currency and absolute levels. But the interesting thing you can still take from this are going to be the relative jumps you see between the different roles. So when we go from business analyst to data scientist, we're going to see a premium that my guess would be that it holds up across geographic region.
Yeah, definitely.
So David, how would you define a business analyst?
So for a business analyst, I always like to think of it, if you really enjoy project management and making sure projects are delivered on time and they don't go over budget, and you like to worry about all the complexities and things that can go wrong, this would be kind of a perfect job, for you. So business analysts, they usually focus on data. And if you are in a data specific project, sometimes they call these people technical project managers, where they are maybe working on an enhancement to a website or a different data app that they're rolling out, to a website. But really what they do is they gather requirements from the users, both internal in a company and then also your potential customers on a website. And they just make sure that whatever data product you're building will meet all of those requirements ahead of time. So there's a lot of documentation, and if you've heard of things like agile methodology and Jira, there's heavy use of that technology here, where you're documenting things called user stories. And there's a specific format to all these. They always start with, as a user, I should be able to, right? And so they have to go around the business and ask everybody, if I build this for you, what do you expect it to do? What do you need it to do? And they just make sure that all of that is met on schedule, on budget. And they also have to plan for the resources. So if you're working with big data, they have to think about, well, maybe I need a big data engineer to be able to solve this problem in an efficient amount of time, and things like that. So it's a lot of project management, but much more focus, I think, on data and technology, which makes it stand out just from a general, event planner maybe, or project manager. You do have to have a lot of that data knowledge to succeed, I think, in this role.
Yeah, and I was in a few roles, especially when I was a market research analyst, 10, 12 years ago. I always thought what was interesting about this role was that, especially if you're early in your career, because you're on the analyst side of these business teams or these product teams, you are able to lean on that data to sort of elevate yourself from a seniority perspective. Because it's hard when you're 25, 26, 27 maybe to really have a voice at that strategic table. But when you come in with data on your users or with data from competitive analysis, you have the ability, one, to talk to the people that are probably buying the products that your company might be selling. But more than that, you have the ear of the senior leadership in many cases, especially if you're in a smaller organization, and you're giving them the data they need to start setting the strategic direction for the organization. So it's a fun role that I think gives you exposure in a way that is good, both from an interesting point of view, because the data you're looking at should be, it's fresh, it's changing, it's interesting, but also in terms of that access, you probably will get to somebody who's a little bit more higher up.
Yeah, yeah. It's a great way, I think, to build trust with leadership at any company. If
Yeah.
you're really good at that type of stuff, if you're the lead business analyst, you really understand the business and you become kind of the go-to. They'll come to you for advice if they think about changing strategic direction or anything like that. And that's always a great position to be in. It allows you to move forward to better roles maybe in the future. And yeah, it's all good.
Yeah. And then I think what's neat about it, when you start looking at the tools that are being used, as we're going to see, they're going to be the only role that we're looking at where Excel is the most commonly referenced one. And I think as of a business analyst, typically as sort of like somebody who's a data opportunist, right? They're usually going out and finding data that's available within an organization. So they're going to be relying on other units to surface the raw data for them, or give them tools where they can access it in a clean way. But they're going to get a note from their manager or their manager's boss that's going to say, can you grab these numbers and do a quick analysis for me? And for that, it's okay for them to jump into Excel, throw some numbers in a spreadsheet, make some assumptions, make some tweaks, do a simulation, do some basic forecasting, and then fire it off and go back up there. So I think that's like probably still a dominant or a predominant responsibility of the business analyst. And then when you get under the surface a little bit, you start getting into more dashboard usage. So not necessarily dashboard creation, although I'm sure some do, but being able to say, here are the dashboards that have been made available, maybe from our data team, our data science dedicated team. How can I use the information in here to do ongoing reporting within my organization, to grab a few data points I need to help fill the gaps on some of the projects that we are considering. So going out and using this information that's available. The other distinguishing point of view, again, is on the customer analytics, the product analytics. So here we see it with a lot greater frequency than the other roles. We need these people to integrate themselves on really product teams, on consumer facing products or service teams, to be the voice of data reason, or to quantify the issues faced by the end user, or as David mentioned earlier, the process to get something ready to launch. Mm-hmm. So that's what the business analyst looks like. And you can see again from this overall US salary average, we're looking at $75,000 annually. And this is the average, and there's a lot of noise underneath. But when we jump ahead to the data analyst, we're going to see that the salary is relatively similar. And I wouldn't pay too much attention to being down a few $1,000s here. And I think in probably some organizations as well, there's probably some more blurring even between the data analyst and the business analyst, depending on what the expectations are. Mm-hmm. But when you look at the stats here, just from your experience, what is the biggest differentiator between the business analyst and the data analyst, David?
Yeah, so the data analysts, they are usually expected to know SQL, definitely, and how to get raw data out of a company's systems and create reports and and things like that. So they usually typically hand that off to business analysts to be able to do their competitive intelligence and things like that. So they have to be much more familiar, I think, with technical concepts like database design, kind of the optimal way to store data to make a dashboard be quick and efficient so people can access them. Yeah, so I would say the amount of technical expertise goes up by quite a bit, and they are still working on the business side. So I've seen a lot of data analysts work on creating things called KPIs, so key performance indicators for a company. So this is where you're asking the question, what is important for us to track as a company that will measure our success over time. And usually there are hundreds, sometimes thousands of ways you can do that with the data you have and the different businesses that you might be running. So you are kind of that trusted source where you use your analytics knowledge, your knowledge of statistics and data methodologies to be able to help them create that, and then you help create the dashboards to track those over time, and you become the go-to kind of expert on those KPIs. Yeah, so very similar, but pretty distinct at the same time, from business analysts. Yeah.
Yeah, I think a lot of the times those KPI generation meetings come from you're sitting down with somebody who's probably has a more strategic role, and they're saying, we need to collect this. And the data analyst says, well, I know our data catalogs well enough. I can go bring together this data, connect it with this data, and make this metric a reality. Versus the business analyst who might just be tracking it and reporting it, over and over again.
Yeah, and that's a good example. I mean, a lot of the times when you and I used to work on projects, we used to have to do market sizing, so this is where the business analyst would be asking, is it worth doing this project? Do we have enough people in the market to even sell to? Will we make money? Will we be profitable? But then it was up to the analysts to go get that data. So we had to go and get country population data, for people that are 20 to 29, and look at the trends in the future. How's that population going to grow? And so these are the people that we're potentially selling to, right? So that's really what distinguishes the data analyst is you can go out, you can go get that data, you can clean it, you can prepare it, and then deliver it to the decision makers, so that they can do their job.
Yeah. And I've always thought about like a bit in terms of progression. I think a business analyst might be more likely to go and run a product team, or be head of product or be a product manager based upon that experience.
Yeah.
I see the data analyst, maybe I'm wrong. A lot of people have this, it's like a stepping stone aspiration to get into something like a data scientist.
Yeah.
And we see that coming through in the data here, where you can see, nearly a third of these job posts are also already mentioning Python and R. So it's not, it's not the majority, but they're bringing up these statistical tools that allow the data analyst, much more so than the business analyst, to be able to do some of that more advanced analytics, to be able to start making code that might be able to turn into something that could be run in production, or turn into something that's like an ongoing value add for an organization, which typically is the data scientist sort of bread and butter.
That's right. Yeah. And another common progression I've seen is data analysts will become the director of analytics as well. That's a common. So if you really like dashboards and databases, I mean, that's a perfect role, director of analytics. So you're really involved in managing the dashboard for an organization, and maybe going out and collecting new data and cleaning it. And so if you really love that, that's a great, kind of progression as well, which is that's not quite data scientist. It's different because it has much more of a reporting business intelligence, as it's called, focus, versus the data scientist, which is much more on the machine learning side and creating data products using modeling and things.
Yeah, and you notice here, data visualization comes up as one of the top techniques on the lower half of the slide, is higher than what we'll see in any of the other ones as well. And obviously, data visualization, dashboard generation, BI tools, they're really coming into their own, and every organization are building some. Some people are making careers out of just being data visualization, BI dashboard creation specialists.
They're called Tableau developers. I've seen Power BI developers.
Right.
That's exactly what that is. You're a data, analyst, but you focus in on being very good at Power BI, delivering these dashboards to people. Yeah.
Yeah. All right, then let's get in from here. And again, keep your eye on this average salary. It's going to go from about 71,000, and then a big jump here to about 106,000 for a data scientist. David, you are a data scientist. I think that's how you would probably define yourself at this stage in your career, right?
Mm-hmm. Yeah.
What's it like being a data scientist?
It's really exciting. And the one thing that was very different. So initially I thought, when you're a data scientist, you do just heavy machine learning and mathematics and just kind of deep coding, for the majority of your day. but it's been a lot more about leveraging kind of your knowledge of the business to help them use their data to build awesome products for them and awesome models for them. So there's a lot of that business component that was skipped over, I think, in a lot of the courses in early education, at least in my career.
Mm-hmm.
But I do spend a lot of time talking to people in the business and cataloging how data is generated and why they need a certain product to work. And then you do a lot of translation. I think the reason that the salary jumps so much is that as a data scientist, you do usually have to have a background in mathematics and statistics and really know how these models work. And then you use that knowledge for when somebody approaches you, hey, can we build this data product? I want this thing to be able to classify images as good or bad or things like that. So that's where you have to use that knowledge you have and just to see if that's even possible with the data you have. And how would you tackle that? The methodology, you have to come up and research how you would do this. And sometimes you have to come up with custom algorithms to do that. I've had to do that prior, in my career, where something just didn't exist to meet that specific goal. And you find something that's similar, and then you have to tweak, the algorithm and the mathematics behind it, maybe how you calculate distance between things. So you definitely have to have much more, I would say, mathematical knowledge to be able to do those things well, at least all the translations. And I've heard a term, I think, data translator. Have you heard that before?
Yeah.
That's kind of sometimes people call this that role, the data translator, where you're just able to see a company's data and you hear the strategic direction and where they want to go, and you're able to build a model for that achieves that goal, right? So that's kind of a lot of what data scientists do as well, and we think about.
Yeah, and I still think, and I've met many different data scientists, and clearly everybody's a little bit different. But what you mentioned first here, it wasn't about, you said they need advanced mathematics, that you need statistical mindset and skills. But the first thing that you mentioned was business acumen and the ability to talk to people and understand. So what really separates you, and you'll separates you as a good data scientist, would be that ability to translate or communicate what is going on, what can be done with your data tools, what can't be, what data you have that's going to help to get to that objective, what data you don't have that you might be able to get. These are all conversational based that ultimately will determine how successful you are as a data scientist within that role.
Yeah. And the one thing that I think is uniquely a data scientist activity is what we have as the last step there, the feature engineering, as it's called.
Mm-hmm.
And more broadly, that's just called knowledge representation. But it's just, the underlying mathematics of the models, what they expect. And it's usually, you need to have one row, and then you need to have things called features for the thing you're predicting. So if you're trying to predict whether a customer will purchase something or not, you need to have columns for that customer that says, days since their last purchase, the total amount they've spent in the last 30 days, 60 days. And so those are all those kind of features you're creating. And that is still done manually for the most part, using your knowledge of the business and what you think is really important that's going to drive good performance on a model. Because machine learning, a lot of people think that I just dump data into it that's unstructured and all over the place, and it's going to predict stuff for me, right? That's not how it works. Usually these models need to have a well-defined set of things called features to do that, to find the patterns in it. And so you're spending your time doing that, quite often. You're digging through really messy, dirty data sets and coming up with a way to aggregate them to create these nice features for your models. And I think these days there's a special subset of data science called or databases called feature stores. It's that important, where if you have all these processes to create these features for machine learning, you need to have a place to store them and take snapshots of those features and be able to share that across the business so they could use it for modeling as well, right? So that's still and that's that fine line of understanding the business and being good at mathematics and putting that together, and then you can have really successful data products.
Yeah. And you're doing this all, of course, programmatically. So you need to be a
Okay.
good coder by this stage as well. And we noticed going from business analyst, which was like probably 5-10%, programming skills being asked on these job descriptions, to pushing 20 or 30% on the data analyst. Now we see on the screen here that 3 out of every 4 roles that comes up for a data scientist that we looked at, a couple thousand, I think, 75% of them said, Python is something we need. R programming, kind of a close second, with more than half also being up there. But being versatile in one of those languages, it is really a must for you to be a data scientist today. And what I found super valuable about just coding in general, and David and I right now, we can go back and forth between R and Python pretty well, because once you get the basics of what programming is, and what tools can be there, then it's a matter of just searching Google and going to Stack Overflow or going to some documentation and finding out how you do it in this other tool. But what I like about the data science path, or the data scientist path, is that all of those tasks that David mentioned, you're essentially writing scripts still manually for a lot of it. And that might sound inefficient, but it's also a really clear way to think through the problem that you're working through. So whether it's, going out and connecting to a database and getting some data, and then finding a way to clean that data up, and then thinking through, well, what are the variables I need? finding a way to put those and then turn them into features that can be put into the models that are going to be run. R and Python are definitely at the center of this.
Yes, absolutely. Everything has to be 100% coded if you're doing data science, because it has to be reproducible. So somebody else needs to be able to run it and get the same exact results that you did. So that's, you definitely cannot do things in Excel anymore, because you can't really save the steps or reproduce it and things like that.
Do you see in the next 5 years anything aside from Python or R being the center language, or the primary language for these type of activities?
Well, I mean, what I'm kind of seeing is that Python is becoming a part of almost everything in the data space these days. And there are other tools that are better than Python, because something like Spark, Apache Spark, right? That's great for big data. Python cannot work with big data. It's just not designed to do that. But what people are doing is they are writing a kind of API in Python on top of all these new tools that are specific. So for Spark, it's something called PySpark. So the syntax is slightly different than regular Python, but you're using the same kind of data structures and ways of coding. So somebody that knows Python can be really good at that. And so what I see is just a lot more of that. I see a lot of Python kind of interpreters almost on top of these cool new tools, just to get things going, because it's going to be hard to get out of Python, because it's in everywhere, right? We have web development. You can build Python. You have data visualization, data science. I mean, it's everywhere, and a lot of people know it and they're good at it. So for a company, that just makes sense. Why not have everybody use the same language across all your teams? It's much easier to manage.
Yeah, that's what I was going to say is, I started off in R, and I think David did as well when we were first, getting going with this stuff. And R is a fantastic language. There's so much you can do with it. It's so stable. It's easy. I think easier still to get started with. And it wasn't until 2 years ago when I really started building websites that Python just made a lot more sense for me to build complex websites with an established community and framework around it. So I think, I don't, I think it's, what is it? Julia is another language that's being developed that has some data science capabilities. I've seen some people champion and say this is going to be the future of it. But I think at this point, Python and R, maybe depending on your purposes, maybe a little bit lower these days. But either one of those for the next 5 years, this is going to be the language that puts you in the data science position. And I think as you're going past this stage, as we've gone from business analyst to data scientist, once you get to the more technical side of this, that computer science side, here's where we're going to see Python's real benefit even in terms of communication, and as David said, translation maybe, between the two roles here that have to work together for a lot of roles today. So watch what happens when I go from this data scientist to a data engineering. So we're looking at Python at 75% and R at 55%. Here's data engineer, Python 66%, and R is not even on the list anymore at this level. So this is not to bash R. Again, David and I are certified trainers. We love R, and I still do a lot with it. But as you get into sort of this more computer science space, working with data engineers, putting models into production, going on into web development, Python seems to be more represented in terms of people doing the actual work today.
Yes, yeah, because Python is really the only one that has the connectors to all these technologies that data engineers use in production, to Spark, to SQL, right? So you can really put everything together.
Yeah, and by default, they're on web servers, or Python is usually included in a web server where R isn't. So you typically have to install additional information or additional software, which can be done, but it just gets a little bit more complex.
Yes.
The other thing we can note here, so again, high Python levels in data scientist, data engineer. We see that the salary level is similar again to the data science role, it's data scientist role. So we've had the two analysts kind of at one level, and then we've got data scientists, data engineering around this 105 to 110,000 average salary. David, as someone who's done a lot of machine learning recently from a data science hat, how much have you crossed into the data engineering role? And when you cross over, what do you see them doing that is different from the data science work that you've been tasked with?
Yeah, so I've actually lately been doing a lot of data engineering work in my current role, just because I really had to wrangle a massive amount of data and put it together before I could even think about building models. And it's just a very different experience. It's a very different day if you're a data engineer. So you're doing a lot more coding. You're not necessarily interacting with the business as much to think about things like KPIs and strategy, but you do interact with the business quite a bit when you're talking about data strategy. So what data do we need from which sources? On which schedule? How often does it have to be updated? Do we need this dashboard in real time? So I had that happen actually this year. I had business users that needed real-time updates. As soon as they sent an email, they needed to know exactly when somebody opened it, without a second delay, because that mattered a lot for their business. And so those are the type of things that you're gathering, and then you're writing these systems. So if anyone has ever heard of the term data pipeline, that's really what you're doing. You're writing the code to go out to databases, to go out to the internet, right? Pull data, clean it, and then push it to a nice clean dashboard or a database, or give it to data analysts that can do things with it, and data scientists that can build models. Yeah, so anytime I was doing more data science work and I met up with the data engineer, I would always want to buy them coffee, because I knew that I couldn't do my job without their help. Because if you have to spend your time going out and collecting data and making sure that it's quality, it's clean, doesn't have errors in it, you're going to spend your whole day doing that, and then you're not going to get to modeling, right? So it's almost a prerequisite for being able to build great models. And that's what these data engineers do. They're kind of like the unsung heroes of data science, because they're kind of in the back end. They're making sure everything's right. There's no kind of messy data going in there, and they're worrying about things like governance and data privacy. Make sure data doesn't leak out and people don't access it outside of your organization. But it's absolutely critical, for them to do that. And yeah, you're just usually not as involved, I think, with the kind of business stakeholders. Usually the data scientists are.
And the way it's getting done has changed a lot in the last 10 years. I remember when you and I had to sort of ask for special permission to get physical server blades, I think they were called at the time, put in the server room because everything was local and on site. But one thing that you notice here on the data engineer role, the top technique that comes up is cloud computing. nearly a half of the roles were bringing up cloud computing. And it was about 20% on the data scientist side, probably because their interactions with the data engineering team. But clearly, this cloud computing is where, data science is being achieved these days.
Yes, yeah, definitely. And the data engineer, I think it's a great, title, engineer, because you're really building infrastructure. That's how you should think of it. And back in the day, I mean, when we started in data science, we had SQL Server and things like that, but we had physical servers. So these were physical machines, the size of this right here. And we had, I think, maybe 10 of them in a room with a huge fan that just overheated easily. And you needed some special badge, remember, to get into that room. I was never able to get in, right?
I got in once, yeah.
Oh, yeah, like somebody would have tackled me or something like that. But so back then, they were called database administrators or something along those lines. It was very SQL based, and they were maintaining all of these machines and servers to be able to store the data, send it, and build dashboards. But you're not doing that these days. You're doing that same task, but in the cloud. So you're doing it using the resources of Azure or AWS, but you still have to build basically all the servers and connect them and make sure that data can pass through them, without being hacked and things like that. So it is definitely an engineering role, for sure.
Yeah, and then when we go we talked yesterday about this. When you go from data engineer to data architect, now we're sort of moving back on to the more senior level, the more managerial role. But you define data architects as really just really good data engineers who have a good vision and a good picture for what an organization should do with their systems, how they should set things up so they can be most effective.
Yeah, you have to have a really deep knowledge of, I think, the cloud architecture and all the tools that are available and all the components in the cloud. And then it's almost like a data scientist. When someone approaches you with, can we build this data product? You're using your mathematical knowledge to say yes or no and how you would approach that. This is the same thing, except that people are coming to you with, I need to capture tweets in real time for this person. And right, so you have to think about, well, what's the best way to design that system of capturing tweets in real time and processing them and shipping them out to a dashboard, right? So you have to have done that usually in the past, be really good data engineer, but now you're just at that senior level where you can design the system and then tell more junior data engineers to go implement it. So you kind of guide them to do it correctly.
Yeah, and you see here, the salary, you're going to get a salary bump again because it is typically a higher level role, requiring more work experience. But what I think is neat about the differences in the techniques being required, you start seeing some stuff here that wasn't on the data engineering role. So customer analytics, product analytics are coming up a fair amount of the time here, because no longer with this role are you looking just for someone who's technically capable enough to set up a system that can be run for a specific project. You need somebody who can think holistically about how the data assets can be organized in a way that can support those other business activities, whether it's product support or customer support. And you also see things now, data warehouse comes up for the first time this high on the list. So, where is everything being stored? How's it going to be accessible? How can the team of data engineers continue to bring in data, clean it up, make it accessible for the business analysts, data analysts, to do analysis, for the data scientists to start building models and creating new value beyond it?
Yeah. You're just doing a lot of system design. You're using all that knowledge you've accumulated over time, and you're designing really efficient, scalable systems, data systems for a company.
Yeah. And then our final role, it kind of goes into that C-suite level or that executive level. So for everyone's heard of a chief executive officer, the CEO, or the chief financial officer, the CFO, et cetera, et cetera. But increasingly now we're seeing companies hire these kind of chief data officer roles. And I think it probably leads to a little bit of tension at times with the chief information officer's role, because historically they oversaw sort of computer systems within organizations, and now just different things are being asked of that. So I've seen some cases where that kind of role is reporting into the CDO, or they're sort of on the same team reporting to the CEO. But again, here we're just thinking higher level. You see, to be honest with everyone, we probably only put through on this late last year, maybe 15 or 20 chief data officer job roles. So the numbers are not as high. And the salary data jumps up here to 200,000 because we're talking about this executive level. And there's, I think, a lot of pressure. Dave and I were talking about this as well. A lot of pressure on these people because there's such hype around data today and what it can do for an organization. So if an organization is struggling, it's very easy to be like, well, we have all this data, we can just use this, we're going to recover and start growing again. And it's not that simple in terms of executing on these data plans, but also now the amount of legal and ethical scrutiny that's going to come through both internally and from people who use your products or somehow are exposed, or somehow you might expose their data to a situation that could go poorly. That, there's a lot of stress there. And you see on the top of this list and the techniques on the bottom right, data governance is the one that comes up the most common for this right now. So for those on the call that haven't been involved with data governance before, typically you're pulling in people from legal, from marketing, from your product teams. You want representation around your company, but you've got to find out a way of, if you're being asked through senior leadership, which most people are, to make more data-driven decisions, it means more data needs to be put in your hands. And we want more autonomous decision makers using this data. And if that's happening, the chance for someone accidentally or intentionally using it in an inappropriate way, either legally or ethically, it increases here. So not only does the chief data officer have to find ways to position the data in a way that's going to create value, either internally for decision making or maybe externally with new product development, they also have to safeguard the whole process, or in many ways that they're responsible for that.
Yeah, it's a lot to think about. And all I think about with CDO roles is definitely lawyers, AI ethics, bias in your modeling, all these type of things that really you have to worry about. So you're definitely not, kind of in the weeds and doing a lot of coding or anything.
Right. Which you can see here, right? Like you look at the top tools, the tools don't really make a lot of sense when I first looked at them, but they're also so low. We're looking at, very small number of mentions because it's all about the techniques. It's all about the concepts in terms of how you can sort of safeguard this. So these are the roles we looked at today. We talked through these 6 major roles that we see coming up most commonly. The first 4 very doing, action driven. The 2 analyst roles, data scientist and data engineering. And I thought it was neat to kind of look at the most common tools we hear about today and see kind of along the spectrum of Python, for instance, which role is using it the most. So if you're going to be a data scientist, as we mentioned, you're doing some programming language and you better be really good and really efficient at it. If you're a data analyst, you would probably stand out, or it would help you advance your career if you wanted to go the data science route with programming and one of these languages. But on the data science side, when you get over to statistical analysis and machine learning, that's kind of what differentiates that role right now. And it's very clear when you look at the job numbers coming from this.
Yeah.
You see kind of a cluster around this, being able to either connect or change connections to visualization tools. So the data analyst here specifically on that, we talked about data visualization with them earlier. Excel is going to still be relevant in those first two roles, the 2 analyst roles. Once you get beyond that, it's assumed that you're going to be able to do it. We still see job maps these days that say proficiency in PowerPoint, Word, and Excel, which cracks me up because I think most people generally are, but you're not going to be tested on Excel when you're going for the roles that are at this data scientist level or below.
That's right. Yeah, I was tested on Excel. I remember when I started my first job.
Oh, okay. Well, your first one, not your last one.
No. Yeah.
Yeah.
So that definitely doesn't happen anymore.
Right. And then the other thing I liked about this was just where cloud computing sort of jumps out. So, it makes sense at the highest levels for the engineers and the architects. But data scientists increasingly need to be comfortable in that environment as well. And I remember when I went to the first job that big data was actually taking place. Getting into Databricks for the first time and having to use that to start making connections. It was a challenge just because it was a new system, and for me at the time, actually doing the Python in there it was new for me as well, 6-7 years ago. So it was a challenge. But I think if you are already a data scientist, or you aspire to be it, along the way that you're picking up your statistics and your math and your programming, trying to find some ways to gain some comfort within the cloud computing environment will make it either easier for you to assist and help out, or at least empathize and understand what the people that you're going to have to collaborate with, data engineers primarily, are going to be doing.
Yeah. Yeah, it can only, I always tell everybody to learn cloud computing, because that's just the future of everything, so everyone can benefit from understanding how it works and why it's better than just having your laptop at home.
And what specific tools would you say to start learning cloud computing with?
And it depends on, I guess, the industry you want to get to. So I would figure out the industry you're interested in. Do they use Azure more, or AWS, or Google Cloud? Because usually there's kind of a divide. And then after that, I would just go to their, they usually have some sort of cloud practitioner certificate, or Azure has a cloud fundamentals, for example. And that's really geared towards business people. You just understand how it works and why it's beneficial to a business. And I think that's good for everybody, whether you're a data person or not, just to be able to understand that.
Yeah. And that's a great segue into our last slide. I've kept my eyes on the chat box and Q&A. I don't see any questions coming in right now. If you've got any, please put them in now. But what we'll leave you with, our assumption is, if you've come here to learn about these different data roles, you probably want to learn some of the tools and techniques that we've been discussing. And this is where the website that we've been building up for a while now comes into play. So if you go to dataquery.com, I mentioned you can find now nearly 2,400 individual data courses and online resources. I think the vast majority of which are now free. And we've grouped together, or David's grouped together, free learning paths through some of these major educational brands that are out there. So say you wanted to become a data scientist. And what I like about this is, even if you find a data scientist path on some systems, it kind of skims over some things that are not as sexy. And David has put these non-sexy things in this list for you. So I think David was just referring to the Azure Data Fundamentals course that Microsoft puts out there. But he's saying, start almost right away with the cloud that you're going to be working in. Get an understanding of what AI is like from a practical point of view. Think through that business acumen with communications and decision making. Start getting into SQL. You got some college algebra. There are all these things that are not on the typical list that people would say when you first want to become a data scientist. But these are going to give you that well-rounded tangibles to actually go through and probably add more value and to be a better data scientist at the end of it.
Definitely, yeah. These were designed to just build up your foundational knowledge, I think, to be really good in this field. And just it touches on all those different components.
Yeah.
And it's great because it's all free. It's either, I think, through Coursera or Microsoft or edX, and it's just fantastic. I said during our last webinar that I wish we had this,
yes, for sure,
12 years ago. But now, it's just so easy to get in there.
Right. And anything that can come to mind. So like, say you wanted cloud computing, right? So I'm just going to type it into our search here. As you can see right back, we'll be able to see all of the MOOCs that are available for it. We'll give you the ability to filter down and say, only show me the free ones that you have available for this. And now you still have 23 that are up there. And when you get into something like Python, we're going to have more than just MOOCs available. We're going to have online cheat sheets. We're going to have online textbooks. We're going to have online courses. So please do check out dataquery.com. There's a lot of information up there. It all comes from David and I teaching in the past and people asking us, what should I learn next after the course that you just taught? And we didn't think that there was a good data specific resource up online that brought together all the amazing content is out there. So if you have any questions on it, feel free to reach out to David or I at any time. Thank you so much for your time tonight. Tonight, Amsterdam time, this afternoon, David time, and wherever you might be in the world. we'll reach out and we'll share the slides and we'll share some links to some of the resources we were talking about. And we really appreciate your time today, and we hope to see you on the next one. Thanks so much.
Absolutely.
Yep. Thank you, David. I appreciate it. And we'll talk soon.
All right. Thanks, everybody. Thanks.
All right. Bye.
Bye.